Today we're learning about the volume of prisms, so let's quickly review what a prism is. Prisms have sides or faces that are polygons. Two of the sides are the same shape, size, and are parallel to one another. These are called bases. Just like with two-dimensional polygons, the bases of prisms are parallel. Also, just like with polygons, the height of the prism is the perpendicular distance between the two bases. So if we look at these three figures, we can look and find the height between the two bases for each of them. Let's start with the triangular prism. We know that the bases are the two triangles. The height is going to be the perpendicular distance that connects those. So the height is going to be this line. It's the line that connects the two bases. It's going to be perpendicular to both of those bases. And we know that a height is perpendicular to the bases by the definition of height that we learned when we were learning about bases and heights with polygons. Same idea here. So these three green lines are all heights, and they're all going to be congruent. So these three heights are congruent. Now, if we look at our pentagonal prism, we're going to have 5 heights that are congruent. That's these 5 lines. If we look at our square prism, or cube actually, this is a cube very specifically, these are all the heights. If we look at the red as a base and then this back one here as a base. Now if we were to look at the blue face as a base and the back one as a base, then we would consider these 4 lines the heights connecting those two bases. So when you have a rectangular prism, we learned it doesn't matter which two sides that you choose to be your bases as long as they're opposite one another. So let's move on from there and review. What type of prism has all sides congruent? What do you think? A cube, right? What type of prism or prisms is it impossible to determine which sides are the bases? Well, I just mentioned that, right? Any type of rectangular prism. And rectangular prisms include 2 other types of prisms. Can you think of what they are? A square prism. And we think of a square prism. A square prism has 2 bases that are squares, but the sides are rectangles. And then we have a third type. What was that? A cube, right? So a cube is also a type of rectangular prism. What is the shape of all sides, not including the bases, of all prisms? So the sides that are not bases always have the shape of what? A rectangle. And how many rectangles will you have? How do you know? How can you look at your shape and tell how many rectangles will be there? The number of rectangles is determined by the shape of the base, or the polygon that is the base. So the shape of the base determines the number of sides, not including the bases. So just to reiterate, for example, with a triangular prism, we're going to have 3 sides that are rectangles, and that's 3 sides not including the bases. With the bases, we have 5 sides. So let's talk about volume. Volume is the amount it takes to fill up an object. So volume is how many cubes will fill up an object. Since we have a 3-dimensional object, it's how many cubes. When we were dealing with polygons, it was how many squares would fill it up, and that would give us area. So volume is going to be in terms of units cubed. For example, centimeters cubed, liters cubed, whatever unit you're working with is going to be to the 3rd power. And the reason for this is we're dealing with 3 dimensions. And we're dealing with 3 lengths being multiplied together, and we'll see that in a minute. To find the volume of a prism, multiply the area of one of the bases by the height of the entire prism. So you just find the area of one of the bases and you multiply it by the height. So if I know the area of this triangle and I know what this height is, the distance between the triangles, which, by the way, is this line, or this line. You can use any of those as the height. They'll all be the same length. You just multiply those together. So I'm going to have to know the area formula for whatever the shape of my base is, or I'll have to know the area itself. So the area of my triangle is 1/2 base times height, and then the height of the entire figure is the distance between the two triangles. So my volume formula for a triangular prism is actually 1/2 base times height times height. Technically, these two heights are different. We really should use a sub 1 and sub 2 to denote that, where the first height, height sub 1, is the height of your triangle. So the height of the triangle is going to be, in an acute triangle, it's the distance from a vertex to the opposite side that's perpendicular. So that would be your height sub 1, and then your base would be whichever side the height is perpendicular to. So this would be your base, this would be your height sub 1, and then your height sub 2 would be this distance right here. If you want to just put height times height, that's fine, as long as you're very clear that the height for your two-dimensional figure is different than the height for your three-dimensional figure. The previous example, when you're finding the volume of a prism, you're going to be using the formula capital B times H. Capital B means the area of the base. So we have to figure out the formula for the area of the base, and then the H is going to be the height of our 3D figure, our prism in this case. So this is what shape? It's a cube, right? So let's figure out the volume formula for a cube. Well, we know the shape of our base is going to be a square. So the formula for a square you could write as base times height, length times width, or more typically we use side squared. And then times H, which would be the height of the figure. You could also take into consideration that the height is the same length as your other sides, and you could actually use the formula side cubed, which is the formula for the volume of a cube. Any of those would be fine. So, but one thing I want you to keep in mind here is ultimately we're multiplying the length times the width times the height. And when you multiply the length times the width times the height, or the side times the side times the side, however you want to think about it, ultimately you're multiplying 3 lengths, and each of those lengths has a unit. So when we multiply side times side times side, we're going to be multiplying 4 units times 4 units times 4 units. 4 times 4 times 4, do you know what that is? 64. And then units times units times units, what do you think that equals? Well, that's units cubed. So anytime you're finding the volume, you will ultimately be multiplying 3 different lengths together, and each one has a unit. Therefore, the unit will be cubed. So when you're working with the volume of prisms, you're always going to use capital B times H as your formula for volume, where capital B is the area of the base and H is the perpendicular distance between the two bases. So with a rectangular prism, our formula is capital B times H, and we can use lowercase b times h, or you could use length times width times height for a rectangular prism. Either one of those is fine. Keep in mind that when we're looking at our two h's, that one of these h's is the height of our base and one is the height of our three-dimensional figure. With a triangular prism, as we saw earlier, you're going to replace the area formula for our base, our capital B, with the formula 1/2 base times height. And then, of course, we'll find the height of the entire three-dimensional figure. And just multiply those numbers. You can put it straight in your calculator. With a trapezoidal prism, our base is a trapezoid, so we're going to replace capital B with the formula for a trapezoid, which is 1/2 the sum of the bases times the height. So this is really a B sub 1 plus B sub 2 times the height. And all of that gives you the area of your trapezoid. And then you multiply this times the height of the entire figure. So the height of the entire figure is going to be the distance between the two bases. And keep in mind that you could use any of these 4 lines to find the height. All of those will be the same length. So pause the video and find the volume of the first picture and then check and see how you do. So I use my formula, volume equals the area of the base times the height. The base is a rectangle, so I could use b times h or length times width. And that gives me 5 times 4 for the area of the base, which is 20. And then the height is going to be 6. So 20 times 6 is 120, and whatever units it would be cubed. Try the next figure. Think about what kind of figure that is. Again, using the volume equals area of the base times the height, we should notice that the shape of the base is a square. Therefore, we use the formula volume equals side squared times height, and then the height is 10. The side of each square is, each side of the square is 3. So 3 squared times 10 gives us 9 times 10, which is 90 units cubed. Now try the next problem. Notice they give you the base area. In this example, they already give us the base area for the trapezoid. So although we have the formula here for a trapezoid, we don't have to use it. We can just replace capital B with 45. The height is 10, so we multiply 45 times 10 to get 450 units cubed. In our last problem, we know the volume and we know some dimensions, but now we need to figure out the height. So use your formula and use some algebra to figure it out. In this case, we're using our trapezoid formula. We're going to substitute in everything we know, and that includes the volume. We know what the volume is. Now we're going to figure out what 1/2 times the sum of 2.4 and 16 times 1.2 equals, and that's 2.4, times the height of the entire thing, which is what we're looking for. We're trying to figure out this height here. And we divide both sides by 2.4. So we end up with height equaling 5 meters. And remember, height is just one dimension, so that's just meters.